Hi everyone. We're a couple minutes behind the hour, so let's start. So today's topic is about troubleshooting microservices, and it's going to be a session where we can brainstorm and freewheel a little bit on how we could potentially get insights in our Kubernetes clusters in the networking, and get some deeper understanding on how we might troubleshooting these kind of environments. There will be some very easy things that you probably all know. Also, we'll address a little bit how you can actually sniff traffic inside of Kubernetes clusters. And afterwards, of course, we do the demo, and we'll also look at how Calico Enterprise addresses this issue when it comes down to production systems. So I'm Philip, I'm a solution architect with Agira. Agira is the company that is behind Calico. My background is mostly load balancing, ingress, that kind of stuff, and security. So I love to play around with Kubernetes, and even better for my understanding is I try to understand the networking and how secure it is. And you'll hopefully see that during this talk. So a very small agenda, it's not the most important thing. So we'll basically look at what Calico is, the most important things to know about Calico, to get a good understanding on how it works, see how we can actually use kubectl or Calico CTL to get a good idea about what we are troubleshooting, because I always think that's a very important thing. And of course, I also love graphs and metrics and UIs. So for the times I don't want to type YAML. So then we'll take a look at Enterprise and how we can use Calico Enterprise to get a better understanding. And you will see the added value of that. And if we have some time left, feel free to ask any questions. If not, drop them in the chat box and I'll happily answer them. So Project Calico, you probably all know Project Calico. It's a slide I always use to introduce Calico. But at the end, Calico is known as an open source networking and network security solution that can exist inside of Kubernetes, so for containers, but also can be used on virtual machines as well as cloud native host-based workloads. So I admit that the biggest focus is on the container part, but if you want to integrate Calico together with, let's say, more legacy apps, or for example, relational databases that are sitting in AWS, well, you can do that with Calico. Share the networking, and also, of course, also adapt the same approach when it comes down to network policies. Why would you actually consider using Calico? Well, when it all is down to 1 or 2 or 3 node clusters or Minikube on a notebook, most environments will probably work. Project Calico and Calico Enterprise. The real cool thing is that it is extremely fast. There were some performance results published by an independent party not that long ago. So it's pretty fast. It's massively scalable. I learned yesterday that we have projects with more than multiple thousands of nodes. So I think I can state that it is scalable. It's also very easy to integrate. We'll talk about that later, because you will see that there are many different ways to actually build the network, as well as use existing networking CNIs in managed Kubernetes environments. So always a good reason to look for Project Calico and all the benefits that go with it. quite some high-end customers. If you're happy to learn a little more about Calico Enterprise, Jane is on this call. Feel free to reach out to her. She will happily help you with that. But let's jump into the technical part. So as I said, Calico is an open source container networking interface and network security policy, and it is actually available in most environments. So there is, as I would say, no lock-in into one or the other cloud or environment. So you can find network security policy integration in all the managed cloud environments. Most of them also support a Calico CNI that can run on top of it. If it is on-premise, I think we'll cover the entire range up to bare metal and VMs. Of course, manageability of a bigger infrastructure requires probably some enterprise tools. We see quite a lot of projects where prospects and customers are looking to multi-cluster, hybrid cloud, dev clusters, prod clusters, test clusters, and so on and so forth. So maybe centralized management and potentially federated security might become an option. Therefore, we developed Calico Enterprise. So when we talk about networking, and since I only joined Calico not that long ago, I had the pleasure to actually try to understand and learn about everything. And I somehow put in these slides where I ran into issues and how I tried to troubleshoot it. So it's, I should say, a little bit an opinionated presentation. So one thing to understand very clearly, and for sure if you want to debug an application or a cluster, is to understand the networking model that is actually in Kubernetes. As you know, Kubernetes itself doesn't have networking implemented. It's implemented by a CNI like Calico. And there are a few rules, basically design patterns that actually are defined where vendors or open source projects have to adhere to. And one of these patterns is that every container within a pod, so just imagine a pod, we always try to mix up a pod with a container, but actually in Kubernetes you run pods, and pods are actually made up out of 1, 2, or 3, or even more containers. Containers that make up a pod share the same IP address. That means that you can have a pod with four containers. Well, they will all share the networking stack. I will use that principle and that idea of sharing the network stack in one of the demos later on. Another thing which is very important and often can run yourself into trouble is all pods are supposed to communicate with all other pods in a cluster using the pod IP address. That means that if a pod is sitting on node 1 and another pod is sitting on node 2, well, if they communicate to each other, they should actually see each other's IP address without any need for address translation. That's why a CNI or a very flexible CNI is important, because it first will take care of the IP address management, but also will make sure that traffic is encapsulated or, as in Calico, is routed towards the correct nodes. So it's a very important thing. And if something breaks in a cluster, quite often it breaks the intra-node connectivity. And then, of course, your cluster will go down or have some orphaned nodes. Kubernetes network model is an open communication path, means there is nothing that actually will block traffic between one pod and another pod. If you want to define the isolation, you have to do that through the use of network policies. Network policies as such, there are two types of network policies. One type of network policy is probably what you know, the Kubernetes native network policies that are available across most CNIs. If you're using Calico, you can use a Calico network policies, which is basically an advanced or an extension on the basic Calico network policies. So take it into account, because even if your cluster is working as you would expect, network policies might block traffic coming into pods, and sometimes even worse, block traffic going out of the pods, like for example, core DNS. So it's very, very important to actually check that. And if you need to put the proof in the pudding and show that traffic is actually leaving the pods or the clusters as expected. Now, another thing which is fairly important to understand when you start troubleshooting microservices is what the Calico network options are that you're actually using. As you might know, there are, let's say, two big or three even big areas in which your networking can go. One is not listed here, which is eBPF, which is something Calico supports. But let's say in 95% of all the cases, or even more, we're sitting in one of the two cases listed here. Very often when we talk about CNIs, there is encapsulation in the game. Probably you heard about Vxlan Encapsulation, which is typically supported by multiple CNIs. Calico can support Vxlan Encapsulation. The advantage of Vxlan is that it is UDP and TCP, so it can actually communicate fairly easily through most firewalls and routers, or the use of IP in IP encapsulation in Calico, which is, if I'm not mistaken, the default when you install it in the open source. IP in IP is a little bit more flexible in the way that it's more performing, and it also relies on BGP. So it's pretty scalable and has a little less overhead than Vxlan. I do admit that Vxlan is easier and a little bit more agnostic, but when we talk about high performance, when we talk about flexibility and scalability in networking design, IP and IP is the way forward, if possible. If you really want to push it to the side, you can actually also opt for non-overlay networking. So in that case, Calico will not encapsulate any traffic. So the IP addresses of your pods will be visible, let's say, on the underlay network. So there is no overhead for encapsulation. Everything is controlled by BGP. The only thing that you need to be careful with in these kind of scenarios is if the underlying network does support it. For example, if you build your clusters on AWS as I did, AWS is not that happy with that kind of setup. And I actually was also caught yesterday that I forgot to turn off source and destination checking. So it's very fast, it's easy, you have pod IP visibility on the underlay network, but it's not always possible to use it in every type of mostly managed cloud. But options, if you have to troubleshoot something, look at these options, and I'll show you. And I'll show you how you can double check that. Traffic in between pods should not be address translated. Very often, traffic in between pods is also in a kind of virtual private network or a private network. If pods need to communicate with the outside world, there is address translation going on. It's not a must for Calico. You can turn off not outgoing. If you can peer, for example, with the firewall or the router, you can turn it off. But let's say most often address translation is turned on when traffic leaves one of the nodes. Take care of that if you want to troubleshoot. That may be somewhere on the underlay or on the router. You're actually not seeing the IP addresses of the pods, but you're actually seeing IP addresses of the nodes. This is all known, but keep it in mind when you're troubleshooting, because quite often the problems are actually somewhere in that region. Not outgoing, by the way, is a question we very often get, is controlled by the pod side that you actually configure initially in Kubernetes. So if you install Kubernetes through kubeadmin, you have to specify a pod side. Well, if traffic is leaving outside of the pod side, well, automatically, unless you control it through Calico, your traffic will be netted. So keep that in mind. Now, beside the networking options and, of course, the network security policies, a very important part that makes up Calico is also the IPAM, or the IP address management. Again, there are a multitude of ways to do that. If you install Calico open source, you're probably using Calico IPAM, but if you're using one kind of, for example, managed cloud, it might be host local or even a cloud native IPAM solution. We're going to focus on the Calico IPAM part here because it allows us, if you have this kind of solution, to easily troubleshoot that later on. Now, how do I typically go around and try to somehow understand my environment? It's always a good idea to start from, let's say, point one, meaning that, first of all, let's see whether we can actually see our nodes or not. I typically use Calico CTL for it, or kubectl. Most commands which are on this page will allow you to essentially use both. Maybe a small syntax. Sometimes Calico CTL shows you a little bit more information, or in an easier way than you might get it from kubectl. So the first command typically says Calico CTL node status. It will give you an idea about the nodes in your cluster and whether the BGP is working as expected. Yeah, so it's already a good sign if you will see that your BGP peering sessions are established, so that you know that your nodes actually exchanged routing information. Now, if you're familiar with Calico, you probably also know that Calico doesn't really use the pod side as an object. Calico will actually use the idea of an IP pool. An IP pool is nothing more than a subset of the pod side. Yeah, that you can actually assign a specific encapsulation type, like IP and IP, or Vxlan, or no encapsulation. On an IP pool, you can also actually control whether we should enable outgoing address translation or not. So Calico somehow makes it more flexible to create multiple pools, so that you can control the networking more generally. Okay. Of course, you can assign pods to specific pools, so keep that in mind. Like in the examples I have in my demo, some pods are using IP and IP encapsulation. Some pods are simply using a non-encapsulated pool. So it's perfectly possible to do that. Sorry. Also a good idea, for sure, if you're playing around with the IP address ranges and so on and so forth, and when you think about sizing your cluster, is to actually check how the IP address management is doing, because there are a few things to take into account. For example, if you're using AWS, you might run into situations where you have very limited IP addresses available. So even if you're using, for example, a native VPC kind of IP address management, well, you might run into a shortage of IP addresses. That's one of the reasons why you, of course, would use an overlay or a virtual range or private range as in Calico, so that you have more flexibility and a broader range. So how do we manage? How are our pools doing? Do we still have IP addresses available on specific nodes? Well, through Calico CTL, you can try to figure that out. Also, use kubectl or Calico CTL to actually grab the IP addresses of the pods. It's always a very good thing to try to figure out which IP addresses are using if you want to test, for example, the IP to IP connectivity. Okay, I will use these things. I'm just listing them up here, so I don't have to jump back.
Philippe, we have a question just before you go off that slide from Sampath, how to find the pod IP range in the Kubernetes cluster, which has been assigned by Calico. I think you just went through it, actually.
I don't know top of my head, but one way would be to, if I'm not mistaken, well, I can look it up, is to basically do a cluster info dump and see if it is in there. If not, it is actually specified in the configuration file of kubelet. But if you install it through kubeadmin, you have to specify a pod cider. But I can look it up. I don't know it top of my head, but you can figure it out. Now, honestly, if you do an if config on a node, you will almost for sure figure it out yourself, what the range is. But I can look it up. I don't know, but already done it a few times. Okay, so once you are on nodes, depending on which overlays you're actually using, like Vxlan, if you have access to the underlying nodes, do an if config. You can see very valuable information also later on to troubleshoot it, because it will actually reveal already if you're using IP in IP or non-encapsulated, because you will see that there are Calico interfaces. As you know, Calico will actually create a virtual interface on the virtual router, which is cool for troubleshooting because it means that you can actually look at that interface. Or if you, using Vxlan, you can actually see the Vxlan interfaces also. The way to troubleshoot that would be different. Where you could actually go and grab some traffic would be different, but it's already a good pointer. Also check the routing. Again, I have a mix of Vxlan, IP and IP, and non-encapsulation just for the demo purposes. But you can also fairly easily figure out the routes. For example, if you see the /26 routes here, these are actually IPAM block ranges, which are advertised. What you're actually seeing here is this node sending actually to two other nodes, in this case 220 and 2170, actually the ranges that it is hosting. Now, this is a difficult way to see it, and you have to decode it all, but through the commands I showed earlier, you can fairly easily see that kind of information. Before we jump in the demos and the practical part, I'm a pretty big fan of, but what if it doesn't work? What if I have an issue with a network security policy? What if a service is not running inside of a container for whatever reason? So I spent quite some time on how you can actually try to TCP dump inside of a container. And I admit in Kubernetes, this is not an easy thing to do. Therefore, it requires that you understand the networking options in Kubernetes, and as such, know where to go and sniff for traffic. So this is not a complete list. There are some tools if anyone is interested, but I find it a little bit daunting to install, which is called Ksniff, which can basically use Wireshark to pull in the traffic, but it requires you to install quite a lot of things that I wouldn't like on my cluster, but that's one thing you can do it. But to be honest, if you think about it, it can be done pretty straightforward. One way to do it works for Docker as well as for Kubernetes is to go SSH into the node and do a TCP dump. Yeah. Now that's sometimes it's easy with Calico. This might be pretty easy to do because of the simple reason that you can figure out pretty easily which interface a pod is sitting on. But if you're using Vxlan or using another type of overlay, this might be a more daunting task to do. And as I said, the list is not complete because some ideas tell you to go into the namespace of the container, which is not as easy as it sounds. So TCP dumping on the node is a pretty easy way, assuming that you have root access on that node to actually do the TCP dump. A second approach I used quite often for sure in environments where you actually only have kubectl access towards Kubernetes is by using a sidecar container. I will show it in a demo. It's not very complicated. I have it documented on Medium. If you want, you can find it. It's a good way to actually inject TCP dump into pods. The downside of this approach is that it will actually spin up a new pod, and when you remove TCP dump, it will restart the pods. Really, if you want to analyze something and keep the logs and so on and so forth, this might not be the best approach. But if you see a broad problem why something is not working in a specific deployment, this will do perfectly. Another approach, which I spent quite some time on yesterday because I overlooked something, is that you can actually spin up pods, and especially in the Calico world, through the host network setting. That means that you're spinning up a pod with some higher privileges like host network. And at that point, that pod is capable of accessing all the network interfaces that exist on the host or the node you're working on. So if you're sitting on the right node, or you can specify through kubectl on which node to spin up this pod, well, you can actually capture all the traffic that is happening, at least from a node perspective or on the network. And last but not least, I spent some time a couple of weeks ago to actually do TCP dump using ephemeral containers. I'm going to go much into detail. I provided you the link, but you can enable some feature gates inside of Kubernetes that allows you to actually spin up containers, and they can actually link without rebooting pods or restarting pods directly to a pod and actually sniff traffic. The link is here, but my clusters don't have these featured gates enabled, so I cannot show this, but it's documented how you can do it. This is the host network example. So if you have access to kubectl, you can actually copy paste this. Basically what it is doing is, you see, it's actually mounting all the network interfaces inside of the pod. You can use any pod that has TCP dump or whatever, but this is a troubleshooting pod I use of my own. And as you can see, I think it's wrongly formatted here, but you can actually specify inside of the pod a resource on which host to actually run this command. At that point, you basically have a pod that can see traffic for that respective node. I'll try to show it live if the demo gods are with me. Another thing I find pretty a daunting task is, okay, once we assume that the networking is okay, we still might run into troubles where actually our network policies are blocking traffic, being incoming traffic or outgoing traffic. So always please check if there are network policies deployed. You can do that through Calico get network policies, all namespaces. It will list you all the network policies that are in place. Now, I admit in huge clusters, that can be a very long list to search through. So I couldn't actually find it, but I found it by accident. If you do Calico get network policies -o white, it will actually tell you to what network policies, to what pods these network policies are applied. So it will show you the labels. I actually figured this out an hour ago while I wrote this long thing to figure it out. But it's an option in Calico Encapsulation. So always check which network policies are in place. Look for things like ingress, which is incoming, and egress, which might be more difficult to troubleshoot, meaning that egress is that traffic is not allowed to leave a pod. There are other webinars that we posted very recently so that you could actually see how it works. Once you actually find a network policy, look into the YAML file of the policy, check the pod selector if you have it, because if you know what pod selector you're using, you can actually pretty easily find the pods to which it is applicable. And don't think that this is easy to see because you see things like zone 1 or something. Just think about pod selector labels. Yeah, they can be or having a totally different naming syntax than the labels you're using in your pods. Your pods can have multiple labels, so a network security policy might actually capture way more pods than only, for example, in this case, Nginx. You have to really look at the labels on it. Last but not least, this more complex example basically tells you the name of the network policy that is applied to a specific label. So if you have a label or you have a pod with a specific problem and it has a label like, for example, app equals echo server 1, well, this command can actually tell you which network policy is actually applied to this label. It's complex, I know, but I modified it a little bit so that it can scroll through actually all the network policies and actually give you which policy is applied so you can find the policy. So try to get familiar with it to see and look in these policies, because yeah, if a firewall is blocking traffic, nothing will work, of course. I don't know why this is, but okay, for some reason. If we're planning to use Calico Enterprise, all this complicated troubleshooting is eased quite a lot, because we can use tools like Flow Visualizer. I'll show it directly, but it allows you to filter through namespaces and so on and so forth and actually analyze which flows you want and actually see which policies are actually being used, whether denying traffic and so on. I'll show that live in a few seconds. Of course, you can also use all the metric data, so you know how many packets are blocked, how many packets are coming in. You have an idea about throughput. So it's also a good indicator whether something is working or not. For sure, the packet count, for example, doesn't tell much, but it at least tells you that packets are getting in and getting out of a pod. So it's a pretty important thing to check. And last but not least, Calico Enterprise also allows you to, I don't know why this is happening. Now even this has disappeared. Okay, cool. It will allow you to actually show the in-depth logging. And then, let me try this finally again. Okay, so I'll show you the logging. And then something new we introduced a couple of weeks ago, and I'm pretty fond of it, is that in Calico Enterprise, you can actually create a packet capture resource. So you can fairly easily tell in Calico Enterprise, for example, in this case, to TCP dump or capture all the traffic in this namespace. So what will happen is if you launch this packet capture with kubectl apply and so on and so forth, it will automatically go for all the applicable pods, in this case, all in a specific namespace, and actually capture that traffic and put it in files on the nodes so that you can actually copy them. So you will find a packet capture per namespace and per pod, which is pretty cool from a troubleshooting perspective, of course, but also later on, you will see that we will be doing way more things when it comes to threat dissection and threat detection and security intrusion and so on and so forth. So look out, it's a new feature, but it works well and can give you quite a lot of interesting information. I'm going to just terminate these slides and then we can jump to the consoles. So for future events, there's even one tonight if you're interested in the integration with Fortinet. There are a few other ones that are popping up. There will be more in EMEA timing. So go to tegira.io/events and you can actually sign up for them as you did for this. So you get the slides and so on and the videos sent to you. And if you're curious about what Calico Enterprise can do after the demo, go to tegira.io/trial. You can sign up and you can actually enjoy all the goodness that Calico Enterprise brings to you, like flow visualization, logging, and so on and so forth. So don't hesitate, go there, sign up, and give it a spin so that you have an idea about how it looks and what it can add as a value. Okay, so the slides are gone. I'm now going back into slides. So I hope you can see it. And before Jane asks me, I'll enlarge the screen. Okay. So let me clear this. So basically, this is an open source cluster. I have here with 2 sessions. So to see if everything is working, you can do keep still, get notes. No, I don't need that. Okay, fine. So just a few words on this. Of course, we can actually see the IP addresses of the nodes. These IP addresses are IP addresses that are actually IP addresses in the AWS VPC. You can actually see there's 1 master and 2 nodes. One thing I frequently see is that status is put to not ready. I don't say it's the only cause, but if it is put to not ready, it very often means that the cluster networking is not working. I say there can be other reasons why, but typically when you install on Kubernetes clusters and you forget or you wrongly install a CNI, the nodes can talk to each other because some core services talk on the IP address of the nodes, but everything that basically use pod IP addresses and services will not connect. For example, like core DNS, and that's very often because your CNI is not working or your cluster control plane is not working. So it's a detail, but look at it because it might already give you a hint. Now, I have two applications running, one in kubectl get pods in an application I wrote to have something that looks like a microservice and I can troubleshoot. So I have one here. You can see a bunch of pods that are communicating through the use of services and with some network policies attached. Okay, so always check that. It's pretty easy to find out if there is a network policy. You can also see that your network policies are actually attached to pod selectors, and these pod selectors are in this case labels which are applied on my pods. So if you go like, always a good idea to type show labels, and you can actually see that your network policies are actually picking up these labels. So take that into account, because once you try to do the troubleshooting, you probably get familiar with it. Yeah. I also have something running in the demo, okay, to showcase something. Now, if I go in there, like do this, something like this, please note that I'm actually using, or that I'm seeing IP addresses that are in 45, 47 network. If I would do something like this, for example, you can actually see that I'm using other ranges. Now, this might be a coincidence, but it is not, simply because I'm using different pools. So to better understand Calico, yeah, let me see. Yeah. First of all, to do that, as I said, use and try to see whether your networking in the cluster is doing okay. So command you have to run with sudo in this environment is to get Calico CTL node status. By using this command, you actually see very useful information that, first of all, you see that I'm sitting in a node-to-node mesh. That's one way to install Calico, so that every node in your cluster is establishing a BGP peering session with the other nodes to exchange the routing information. That's basically why this information is there. Yeah. Whether it's up or down, because BGP is using TCP, so there might be security groups or external firewalls or whatever that is actually blocking that kind of traffic. So always check this. If you see peer type global, it means that your nodes are actually peering with an upstream router. In that case, it might be a little bit more difficult, but check to see that every node knows how to reach every IP address in your cluster. So if you want to know which IP addresses you're actually using, you can actually use something like Calico CTL get IP pools, and then you see actually all the IP pools. So I created 3, which is probably a little bit exaggerated, but it's for demo purposes. So take a look first of all to see what the settings are, because you don't see all the nifty details like this. But if you do things like Calico get IP pools and I'll put it in YAML, you can actually see interesting information. So this is the not the pod CIDR, the IP pool CIDR. Yeah. So my pod CIDR in this case, to elaborate on this, is 192.168/16. So for the IP default IP pool, I'm using actually 20, which is, if I'm not mistaken, from 1 to 31. You can actually see that there is no encapsulation, that I'm using address translation, and there is no Vxlan encapsulation. If you, for example, would check another pool, you would actually see an explanation why I saw this different kind of IP addresses. So as you can see, in the IP pool, I'm using IP in IP encapsulation, and I'm actually using a CIDR 32 and higher. That's why you saw the 45 and 47 in the examples. These commands are pretty useful because you actually know why these pods are having these other IP addresses. Now, there's one thing to note. You might ask yourself, how do you control actually which pods are linked to which IP pools? That's because my namespaces are labeled. So kubectl get namespace show labels. It's not showing any labels for one reason. Sorry, that's not true. You can do it through labels. Sorry, I'm a little bit confused here. But actually, there is no label, and but actually, it's because I annotated this pool. So by actually annotating, by annotating a namespace, you see www.demo is actually annotated with this annotation. That means that if I deploy something in www.demo, yeah, that it will automatically get an IP address of the IP pool. So if we would do kubectl get namespace minus YAML for www.demo, I guess we would see what we need to see. So this is a little bit more difficult to find, but yeah, you have to check for sure if you're using Calico and IP pools, check the namespaces for any annotations if you're actually seeing networking issues, because you can run into a situation where one IP pool works and the other IP pool is not working because of that simple reason. Yeah. Okay. So imagine that we can actually prove that our application is working. Let's see if we can actually TCP dump in our Kubernetes node. So one trick or one way to do that would be to do ifconfig -a. And as I said, the advantage of Calico in this case is that you see all these Calico interface pairs. So if you can figure out which interface is actually used by which pod, you can actually TCP dump on this interface and see the network traffic, which can be a little bit difficult to find out because you need to see the mapping between the VET pairs. So I always find this too complicated, and that's why I don't use it. That's why I typically switch to another approach, and that other approach is, let me get this for you, is to basically the approach I use with the patching. So let's see if it's still there. There is no patch file anymore. So for example, let's see if you can TCP dump in one of these servers in the Nginx deployment. So we're going to see, for example, get pods minus o white minus n demo. No, that was not minus o white. That looks better. So let's see if we can actually see traffic that is actually sitting in one of these pods. Well, you can do that by actually creating a patch. I can share this, but it's on the internet. If you go to the link I showed you earlier. So you can actually update your deployment, insert, yeah, by actually adding a second container. So the name of that container is TCP dump, and I actually use this TCP dump container I created for my own purpose, but it can be any container. So let's do this. So let's verify that we have it correctly. Okay, so we have a patch. So to apply the patch, there are probably easier ways to do that, but you actually say kubectl patch deployment, Nginx deployment, which in the namespace with the content of this file. Now, note that when I did get get pods here, that you see only one container. Yeah, if I would issue the similar command, get po, yeah, that we are having, it's still terminating here, but these three, yeah, have two pods. Why? If you would do kubectl describe of these pods, you would actually see that that TCP dump container is in there. Now, how can you actually connect to this? Well, you know the name. So what we can actually do is kubectl attach minus IT, and we check, for example, this one, yeah, in the correct namespace. Voila. And if that works out, we should actually see TCP dump. So let me go and switch to this other terminal. That's what I need. So let's see if I can connect to this one. kubectl exec minus IT in this container bash in namespace demo, and let's execute bash. So okay, so what if I'm lucky and I can, no, that's not when I'm lucky. I connected to 2QGL. So if I would connect to this, and if I'm lucky, we will see after a while here. Did I make a mistake? Nope. Okay. What you should see is that, yeah, sorry. No, what you would see at a given point is that the captured traffic that will show up here, but sometimes it takes a while. Don't ask me why, but yeah, it's showing up. Let's keep it. Okay, so that's one way to actually look at traffic inside of a pod. It only requires kubectl access, which is pretty neat. Now, the problem at this point is that your pods are still running as sidecar containers. So the way to clean this up is to basically do a pretty unknown command, do a roll alt, undo, and you can actually remove the pods and they will see terminating, and they will be running in 1.1. If you want to do the host networking trick, you can also, it's also pretty easy to do. This is the file, it's in the slide deck. So host networking through, you're spinning up a pod, a separate pod, and through the hostname selector here, you can actually make sure it's only running on the host where you want to capture the traffic. So if you go there, the pod debug is created. If we check, we can actually see that the pod is created. Okay, so if we basically do cube ctl exec minus it debug, and we execute bash. Okay, so I'm in the interface, sorry, in the pod. So if I do an if config, please note that I see all the interfaces of the host. I'm just doing kubectl. So at this point, I can basically do a TCP dump minus any, and to make sure it doesn't kill my environment, for example, TCP dump minus any, sorry. You see, it allows you to capture all the traffic on all the interfaces of a specific node. So that's pretty cool, but there might be some pod security policies that prevent you from doing this. Now, this was, let's say, the hard way of troubleshooting. Of course, there is an easier way. So if you go to the Calico Enterprise trial, you can actually go and see, and once it's installed, you can actually see stuff like this. So it gives you a great idea about how many connections, bytes are allowed in and out, if something is blocked or not, which policies are actually blocking traffic or not. So it is a way more intuitive way to actually go and look inside of a policy to find out what the rules are. Through the use of the inventory, you can also pretty easily figure out on which interface something is running, if you want to do the TCP trick, which labels are applied and which policies are applied. Yeah, so makes life way more easier. If you're running into troubles, why is something not working? Well, you can actually go into the flow visualization part, and if you give it a second to load, well, you can actually do things like show me, for example, all the traffic that is running around in that namespace. For example, you can turn on the labeling so that you actually know which pods are communicating by which pods. You can see all this information. You can even see whether it's connecting to an outside namespace, yeah, to keep system in this case, because we're using, of course, core DNS. Yeah, you can even see whether a pod is connecting to the internet. On the right, you actually see here, if you select which policies are applied, if they are blocking or denying traffic, and which labels are actually linked to it. If you even want deeper information, well, you can also go into the logging system, and then you can actually see this. You can actually see all the flows, so you can actually see all the detailed information for any connection, whether it's allowed, blocked, which port, which source, so on and so forth. So there's a lot and tons of information that we gathered. You can also do an aggregation. So let me see if you do this here, flow logs, yeah. You can actually see that this is a way more nicer view. So you can actually see that it aggregated 27 flows into this definition. So it's basically preventing you from seeing all the stuff 27 times. Another cool thing in Calico Enterprise, which is pretty sometimes hard to troubleshoot, is if you go into the logging, you can also go and see actually the DNS logs. So we can also analyze what pods are doing what DNS lookups, whether it's to services or to external clients, for that matter. And then last but not least, to show you very quickly how you can do a PCAP in Calico Enterprise. I'll enlarge this. So I created this YAML file. As you can see, this is the YAML file here. Kind of packet capture, okay. I don't know what happened. Sorry, here. Packet capture, as I said, selector all in this namespace. So if you do a kubectl apply minus F, in this case, my very test YAML, okay. So it's deployed right now. So right now, I shouldn't say this as a technical guy, but we're doing some magic, and we're actually capturing the TCP dump traffic in every pod. So to stop it, I can actually delete that. If not, it will rotate, but just to make sure. And then you can actually go to this directory. So you can also do it through a pod, but to save some time. So on every node, there is a Calico PCAP. As you can see, there is a directory operable, and I can actually see the information about my sample capture. And as you can see, I have some PCAP traffic here. So if I do, for example, TCP dump min read this, and if I'm lucky, I can see all the traffic that my Calico Enterprise packet capture captured. You can even do, it's called trick minus A, and it actually shows you the output of the data. So as you can see, if there is HTTP, you can even read what the gets, the responses, and so on were. This is somehow what I wanted to tell today. I hope it was interesting. I hope it gave you some pointers to further troubleshoot, or at least get a better understanding of how this can be troubleshooted, or at least understand how it is all working. So thanks. Let me see if there are any questions that were captured. There is a question about performance, which steps check the performance of a website and metrics. To be honest, there are some advanced tools, or advanced like Siege. I typically use, I think there's a Google tool called Worker, if I'm not mistaken. If you go to docxsec on GitHub, I created the file. There are some other tools. Check my GitHub page. I found a graphical tool that, let me see, that can do load testing on Kubernetes, something new. Let me see if I can find it. Yeah, K6. I didn't write it, but it's actually a pretty neat way to do load testing in cloud native environments. Check this out, it's pretty cool. How to check the input output throughput of a pod? To be honest, I think, I don't know, through the host network interface, I didn't ever tested it, but at the end, if you would do an if config here, and you find out the interface of which you can actually see typically if there is throughput on the packets or not. Yeah. Really see the throughput. You cannot, but there are tools that can do that. I used in my very old days iptraf or something. It actually works in Kubernetes, but there's probably something more updated than that. But there are tools, and with the same technique, you can actually capture that traffic. Yeah, because we can see all the traffic as such. I've just thought about it. You can actually, if you do want to know which pod is assigned to it, if you do, I missed it somewhere in the slides, but this command here, this, let me see if I can find it here. If you run this command, if I'm not mistaken, then you can actually see which Calico interface is assigned to which pod. So in that case, if you have Calico, you can actually TCP dump directly, TCP dump on that. Any questions for somehow I went through them. I thank you. If you have any comments, send an email or reach out via Slack or Twitter, and we'll happily have a discussion afterwards. Thank you. Hope to see you next time, and hope it was interesting.